And welcome students as we get into our next unit on File I/O. And so let's start off here with a quick introduction to File I/O. But before we actually get to any coding, we first need to clarify a couple things, primarily the difference between that of a text file and that of a binary file. So getting started in this unit, we're going to explain how you can write your own programs, take input from a file, and send output to a file. Because yes, while user input is very important, it's only one aspect. A lot of times you need to, let's say your program needs to reference a database or it needs to reference file. Think about video games, for example. They need to reference, character models. They have to reference the location of where, for example, audio might be, or where a map might be, or different scenes or elements of a game. The game has to read that stuff in and know the location of it. So this is one way to kind of get into it. File input obviously is not simply just limited to, I'm at a console, I'm typing some commands in on the screen. So in the converse, you also want to send output. Even video games, for example, will generate logs as they're running to help with tracking things, databasing, error reporting, etc. Now this unit is going to cover our most common ways of doing file input and output in Java. Now notice I say the most common ways. It is not an exhaustive study of input-output classes. There is a ton of ways to do input-output. And there's a ton of methods and subclasses and all this other stuff that's associated kind of with File I/O. Because the Java class library contains a bewilderingly many number of classes, an exhaustive treatment, if we were to go through every single one of these classes, it would pretty much be a course all by itself. We could just literally have a class called input-output and just use Java as our language. But for the purpose of this course, it's not needed. If you really want to get into that stuff, you can go to the docs. You can dive into the white pages there and just kind of start shuffling through the document of all the different input and output options that are available. All right, but the first concept we need to discuss is that of streams. Now, a stream is an object that allows for the flow of data between that of your program and some input or output device or file. All right, when I say input-output device, that means, for example, like your keyboard. You're typing characters in on it. A file would be something like a text file. Now, if the flow is going into the program, right, that is called an input stream because you're typing or you're clicking, you're using a webcam, audio, whatever it is. All right, that kind of flow is an input stream because you're inputting information into the computer. So in our case, if the input stream flows from the keyboard, then your program is going to take input from the keyboard, and we've done this actually. If the flow is going the other way, though, if it's going out of the program, that's an output stream. So that's when, for example, the program is giving information back to the user. So if the input stream is coming then from a file, then the program is taking its input from that file. Now, similarly, an output stream can go to a screen or file. And let's just talk real quickly about two little things here, system.out and system.in, because we've seen these system.outs. System.out.println, system.out.print, system.out.printf. We've also seen system.in, for example, scanner keyboard, equals new scanner system.in. That's an example of it. Now, although we may not have realized that these objects were important, we've been using streams in our programs when we had to output something into the screen. For example, system.out, which we use like system.println, is an output stream connected to the screen. System.in is an input stream connected to the keyboard. Now you use system.in expressions such as following, scanner keyboard equals new scanner system.in, which I've already mentioned. Now these two streams are automatically available to your program. Just think about it. Have you ever had to make an import statement to use the, for example, to make a system.in? Now you've had to use a import statement for a scanner, because scanner is a class, but you never had to import system.in. You never had to import system.out. Now you can define other streams that come from or to your files. Once you have defined them, you can use them in your program in ways that are similar to how we use system.out and system.in. Alright, so that leads us right into text files and binary files. Text files are files that appear to contain sequences of characters when viewed in a text editor or read by a program. For example, the files that contain your Java programs are text files. So if you've ever gone into your folder and looked at your .java files, you can actually right-click on them and choose to open, like for example, Notepad, and you can read the files because the Java files are made out of text characters. The class files, on the other hand, are rewritten into, they're compiled into machine language. So you can't right-click and open a class file and expect to read it, but a Java file, you can. Text files are sometimes also known as ASCII files because they contain data encoding scheme known as ASCII coding. So using the ASCII character set to contain the stuff that would be inside. Now, the files whose contents must be handled as a sequence of binary digits are called binary files. So, for example, like your class files are typically much more of like a binary file because they're machine language. Now, although it's not technically the correct way to kind of think about it, we can still think of a text file as containing a sequence of characters, and a binary file is a sequence of binary digits, or binary digits being 0 and 1. This is a little more untechnically correct when we're talking about the binary file, because there's a little bit more to it than just zeros and ones, because there's a lot of other things that go into it to kind of help differentiate the start and stop of values, and etc. Another way to help to differentiate between the idea of a binary file and a text file is to note that text files are designed to be read by human beings. Like I said, you can open up a text file, or like a Java file, with Notepad, and you can read the code. Try to do it with a class file, it doesn't work because the binary files are designed to be read only by the programs. You're not meant to read a class file. You can make one. You can compile it, and it works from your Java code, but the binary files are meant for the machine. Now, one big aspect of text files, in compared to the binary, is that you can read and write to them using text editor. All right, so that's like I say, you can open up Notepad, boom, and look, I want to make a quick change. Type in Notepad, hit save, change is made. All right, similar thing, you can use things like IDEs or different kind of applications to open and edit them as well. Now, with binary files, all the reading and writing must normally be done by a program. In our case, if we take the class files and use that as our example of a binary file, then that's being done when we run Eclipse and we compile our code. All right, we compile our code, it makes a class file. That class file is the binary file. We didn't make it. We didn't go out and code the class file. We coded the Java file, which then when we compiled generated the class file, which is for our purposes, we're going to call that our binary file. Now, one other advantage of text files is that they're usually the same on all computers. So you can move text files from one computer to another with few or no problems. So if I take a text file, take it from Windows, and move it to a Mac, or move it to Linux, it should still functionally pretty much be the same. It's a .txt file. It should functionally be the same. Now, the implementation of binary files usually differs from one computer to another. So your binary data files ordinarily must be read only on the same type of computer with the same programming language as the computer that created the file. That's why there's a lot of issues with, you can't just take, like, for example, an app that was, let's say, created for an Android phone and just immediately stick it on an iPhone and expect it to work, because they use a totally different set of libraries. This is the reason why, because the binary files are different. That's why if you can do things like cross-platform, it's a pretty big deal. Now, the benefit of binary files, despite the fact that you can't just move them around willy-nilly and you can't edit them easily, is that they are more efficient to process than that of a text file. Unlike other programming languages, Java also gives its binary files some of the advantages of text files. Well, one of the big strengths of Java is that it's considered to be cross-platform. All right. Because of that, in particular, Java binary files are platform independent. That is, with Java, you can move your binary files from one type of computer to another, and your program files will still be able to read the binary files. So I can take it from a Windows PC, put it on a Mac, and it should still work. Right? And it's because they're not tied to one platform or another. Now, this combines the portability of text files with the efficiency of binary files. Are there some drawbacks, or some trade-offs that happen with Java being able to do this? Yes, because Java typically may not have as much of the reach on some of the deeper hardware pulls like a language like C++ does, because it has to sacrifice some of that in order to have the cross-platform, but it's all about what you need the application to do at the end of the day. All right, and that's going to wrap our notes up for today, folks. So we will see you next time when we actually start diving our teeth into input and output.